All right, the last type of problem you need to make sure that you can do for this exam is to make sure that you can find the pH of a diprotic acid solution. So let's take a look at this one right here. All right, so in diprotic acids, basically we know that what happens is, in the case of this one, the carbonic acid, that it has 2 protons it can lose. But remember, it does so stepwise. So when I put this in water, it might lose its first proton and produce the bicarbonate ion. So we would get bicarbonate. And then we would also get, not surprisingly, our hydronium ion. However, this also has a proton that it can donate. So HCO3 in water can also donate a proton and end up making just carbonate ion. And again, another hydronium. So we see that we're actually creating hydronium twice. However, notice the Ka values. The Ka for the first step is rather significant, certainly in comparison to the second Ka, which is super, super, super tiny. So because of this, we pretty much ignore the Ka for our second and third, if necessary, hydrolysis of that, our second and third proton. So we're really only concerned with this one right here. So we're really only concerned with this reaction right here. That's right. In multiprotic, polyprotic acids, essentially it's only the first Ka that we are worried about. The only exception to that is sulfuric acid. So if you're interested in how to do a problem like that, we actually did do that sulfuric acid diprotic when we were in our note packet. So let's go ahead and take a look at this one. All others, including this diprotic acid right here, are only concerned with the first Ka. So that having been said, this is my R value. So now I can figure out the rest of my concentrations. So I start with my 0.00125 carbonic acid. Water I'm not concerned with. I should be starting out with no ions in solution, but I'm going to lose some of my carbonic acid to create the bicarbonate ion as well as the hydronium ion. And then finally, hopefully this looks familiar to us. So, since we created hydronium, we are worried about the Ka, and the Ka is told to us. Ka, and this one is 4.2 times 10 to the negative 7, which is going to be equal to the product of my 2 products over my reactant. And so we can solve for x. When we do so, we end up getting 2.3 times 10 to the negative 5. So when I solved for x, what did I really solve for? Well, here's x right here. Aha! I solved for the hydronium or hydrogen concentration, from which I should be able to easily then find my pH. So this is my hydrogen concentration. So pH is going to basically be the opposite log of that, of my 2.3 times 10 to the negative 5, which is going to give me 4.64. So if that's my pH, then my pOH is going to be 14 minus 4.64. 14 minus my pH, which is going to give me my pOH, which in this case is going to be 9.36. So now that I know that my pOH is 9.36, 10 to the negative 9.36 will equal my hydroxide concentration, just in case you're interested, which in this case is going to be 4.3 times 10 to the negative 10. All right, hope this helped.